welcome to the Art of War Analytics Style. My name is Noah Stettler, and I am an associate consultant at Argano Interrel. We at Argano are a consulting firm specializing in digital and data-driven solutions. And for this presentation, I will be analyzing a few lessons found in Sun Tzu's The Art of War using Oracle Analytics Cloud. So a brief introduction of what The Art of War is. The Art of War was a book written by Sun Tzu in about 500 BC China during the Zhou dynasty. So it's currently unknown whether Sun Tzu was actually a real person or just a collective amount of army generals or maybe not even generals, just maybe like philosophers. But currently, the text has proven so influential that it's become a foundational text for most military doctrines throughout the centuries, even up to the modern day. It's also become relevant in just any situation that involves defeating your opponent. And this can be anything, like in business, in the court of law, in just everyday life and beyond that. But for this presentation, we will be actually looking at the actual battlefield applications of the art of war, focusing on data to show just how effective or ineffective Sun Tzu's teachings were. So how can we verify Sun Tzu's lessons using Oracle Analytics? So what we'll be doing is we're going to be using a database of over 600 historical battles between the years 1600 and 1973 AD. This is a database that was distributed by the U.S. Army Concepts Analysis Agency. And we will be using various data visualizations from Oracle Analytics Cloud to examine the battlefield success following Sun Tzu's teachings. And throughout this presentation, I will now be referring to Oracle Analytics Cloud as OAC to keep it easier. So which lessons will we be evaluating? The lessons that we will be looking at involves the effects of weather and terrain on the battlefield, the effectiveness of fire as a weapon using artillery as an example of this, and the importance of battlefield tactics and how all of these effects determine battlefield success for the army using them. So before the project can begin, we can use a feature in OAC to clean up any mistakes you might find in our data. This is a feature called data preparation, and using it, we can modify our data sets before importing them into the project. The various changes we can use for data preparation can involve changing a data column's data type, its aggregation type, its format, and even its name. We can also hide the columns, duplicate, or delete them. Data can also be group, split, group, split, or repaired, replaced, I mean. And it also has this data enrichment feature, which you can see in this recommendation column right here. What it will do is that it uses machine learning to analyze the data to make recommended modifications. Like this one is, it gives you the option to extract part one from the casualty error minus column, which would have created a new column that we could use. But for the purposes of this presentation, I simply use the feature to replace certain data points to make them a little less ambiguous, such as if a data point was annotated, I would instead give the full name of the data point. So how would you handle multiple data sources in a project? So Oracle Analytics has two main features that can help you out with this. The first is to just import the data sources directly into the project, and this will automatically allow the data sets to be joined by a data column that they all have in common. So for this example, all four of the data sheets that I use for this project all have the data column ISQ number in common, which is the ID number identifying the battle. So from that column, they are all joined, and now we'll share their data points across from each other. But to make things even simpler, you could use another feature in OAC called data flow. Now, with this feature, it allows you to join various data sources into one to make it more streamlined. And it's not just joins that you can use this feature for. You can add columns, you can delete them, you can create various aggregations, you can rename columns, and you can even use a machine learning model. But for this project, I simply imported the four data sources and joined them together automatically. Whenever you start a project, it's always kind of intimidating to know how to start. Like you can be overwhelmed with so many data points that you don't know which visualizations to start with or how to go about plotting your data. So OAC has a very handy feature to help with this called the explain feature. It can be achieved by simply right-clicking a data column you want more information on. And the explain feature will use machine learning to provide basic facts, key drivers, and anomalies of the data column that you right-clicked over. And will provide multiple visualizations you can choose from using that fact. And these visualizations can be used as a basis for further modification until you find the right visualization for your project. For analyzing weather's effect on the battlefield, I decided to go with a pivot table and multiple data tiles. And I filtered the data tiles between attackers and defenders and split them according to the seasons. So for the pivot table, I also I organized the various weather combinations provided in the database and took the average success rating, which is 1 to 10 for each of those combinations. And through this, I was able to find that the most successful weather combination for the armies was wet and temperate combination, and the least successful was desert and tropical climates. And I use a color barometer to further highlight the differences in success rating. And from the data tiles, we can also see that the most successful weather for the attackers was weather during the summer, while for the defenders it was weather during the winter. So I ended up using the same format when analyzing the terrain's effects on the battlefield, because it was very similarly structured, like the weather was in the data set. So this way, you can see that the most successful terrain combination was in rolling terrain, and the least successful was in flat urban terrain and rugged terrain. And for the attackers and defenders, they both had the most success in rolling terrain. So further proves that point. So when analyzing the effectiveness of fire as a weapon, I decided to go with artillery because it was the closest modern example to using fire as a weapon in the battlefield. And the visualizations I decided to go with was a scatter plot using success rating and the number of artillery as the two variables. And I ended up splitting the attackers and defenders by color. And another neat thing that OAC has is that it has another machine learning function that allows you to add additional statistics that include clusters, outliers, reference lines, trend lines, and forecasts. And using that feature, I created two trend lines for both the attackers and defenders. And as you can see here, the number of artillery batteries show a general uptick in success for the attackers, while the defenders usually remain about the same. And finally, when analyzing battlefield tactics, I decided to go with a vertical bar chart. And the trail rows allows me to also separate the attackers and defenders. So the very interesting thing in terms of these findings is that you notice that the biggest success rating, the tactics are separated into phases of the battlefield. So the tactics starting from here is like phase 1 and then 2, 3. So it's various different phases of a battlefield. And from my findings, it looks like the more conservative battlefield tactics had the most successes in the first phase of the battle, and then as the battle progresses, the tactics get generally more aggressive, and that's the same for both the attackers and the defenders. You can see here that the success rating in the first phase of a battle for frontal attack is pretty low, but as the phases keep going, it steadily becomes more and more successful, which is interesting because one of the core teachings of the art of war was that Sun Tzu very much put a lot of emphasis on preparation and also discouraging recklessness. So a reckless frontal assault right out the gate of the battlefield, and the enemy, the other side, instead being very conservative and well prepared, kind of proves that. And for the data tiles I have up here, it showed the success rating for armies that just didn't have any tactics at all. And as you can see, their success ratings are pretty low. So the last thing I would like to touch on OAC is that it also has a really cool present tab that allows you to organize all the canvases you created in the visualization tab into a neat slideshow format. From the present tab, you can add further modifications to your visualizations that include adding text and visual filters, layout adjustments, adding notes up in the anywhere on the canvases, and modifying the slideshow navigation and interactivity. Now, none of these changes will affect the visualizations themselves. You can go back to the Visualize tab and they will be fine. So you don't have to worry about permanently affecting your canvases. Nothing will leave the Present tab. And that brings us to the end of the presentation. The original version of this database was distributed by the U.S. Army Concept Analysis Agency, and it was modified by Jeffrey Arnold, and the data set is currently up on Kaggle. I hope you all found examining the R4's teachings on the battlefield interesting, and how it showed just how dense and filled with features Oracle Analytics Cloud is, and how great it can be for data science and analytics.